Believe it or not, this chart is real. These are the actual P99 numbers for T3 chat. We might not be a huge app, but there's a lot of data flowing through it as users sync their entire chat histories. How do we get the performance so much better? That's what we're here to talk about today. There's a new database product by Planetscale that fundamentally changes what you should expect from SQL. Not only is this faster than Planetscale used to be, which is kind of crazy by itself, it's faster than anything else you can do on AWS, even Aurora. As crazy as it might sound, this is the first SQL database you can run yourself on AWS that is faster than the best-in-class options Amazon offers. The things they did to make that happen are kind of crazy, and I'm so lucky I got early access, got to talk with the team. I'm super close with Sam, and there's a lot to dive into here. They aren't paying me though. In fact, it's quite expensive. So if we want to justify the $600 a month that we have to pay for this DB, we have to pay these bills somehow. So quick word from today's sponsor, and we'll be right back. Hiring nowadays kind of sucks. The amount of bad resumes coming through generated by AI makes it impossible to filter through and find good candidates, much less great ones. If you want to hire great engineers and you don't want to waste all your time doing the hiring process, you're kind of screwed, at least unless using today's sponsor, G2I. These guys have solved the problem, and I didn't think hiring was solvable, but with their platform, it is. This isn't just some product you use to comb through resumes. This is a curated group of incredibly talented engineers that they have went through all of the process with to vet already, that they're giving you access to via their video-based platform, where you can ask these engineers questions via text and get back a video interview response. They've already vetted these people. And when I say they vetted these people, I don't mean that they passed a junior interview. If you're looking for juniors, you should go somewhere else. If you want really dedicated, technical, talented people, the ones who work at places like Webflow, 1Password, and Meta, companies that they've helped hire for, this is the place to be. They have over 8,000 engineers. It's a pool of people they took 8 years to craft, and they've all passed their strict technical interviews. I haven't done them myself yet, so I can't say how crazy the process is, but if you guys want me to do that, let me know. They say 7 days from interview to PR is a goal. I honestly think it's more of a humble brag because I've seen them pull this off already, and it's unbelievable. The months I spent hiring in the past make this feel impossible, but they did it. Part-time, full-time, whatever else you need, they almost certainly have you covered. As long as you're in one of the regions that they support, US, Canada, Latin America, or Europe, covers most things, let's be real here. And despite having this awesome video platform, they're not just selling that. They really do start to feel like a part of your team. You set up a shared Slack channel with them, they get super involved with your process, helping you with passing candidates back and forth and talking with you every step along the way until you have a great engineer embedded in your team doing well, or maybe even a whole team of them if you use them for enough hiring. And unlike most engineers, they're actually down to do a weekly stand-up with you if you want. If you're trying to hire great engineers, give G2I a shot. Check them out now at soydev.link/G2I. Before we go too much further, I want to show that this performance has held. The change was done on February 28th, and sadly the history here doesn't go back that far, so I can't show you that it was consistently that 300 millisecond range, but it was. And our P99 has dropped to 45 milliseconds, and our P99.9 has dropped to well under 100 on average. Every once in a while we get a slight spike up to 300-ish, but they're rare. And that means just a small single digit number of queries are hitting those numbers. Previously, our P99.9 was multiple seconds, and we haven't made any changes to the querying characteristics. Normally, you'd see these performance wins by adding indexes, changing how your schema works, or even just fundamentally changing the types of queries you're doing. Maybe you put a cache in front so you're not hitting the DB as much. None of that is going on here. No changes were necessary on our end to take advantage of this new way of doing things, because it's not a new way in the traditional sense. Nothing changed for us. The hardware is what changed. Wait, isn't this on AWS though? If it's not, the latency is going to be terrible. This is on AWS still. So what's going on? How is it possible that this is still on AWS, but it's getting better performance than almost anything else can? It's honestly kind of nuts that AWS's best options that cost thousands of dollars a month can have their QPS just plummet the way that they do, and that a third party is able to get this fast, and often even faster. If you look at some of these numbers, it's crazy how much lower the latency is for what Planetscale's offering than anything else. If it's still on AWS and it's faster, it's got to be more expensive, right? Nope. It's actually quite a bit cheaper. 2 to 6x cheaper. So how? What are they doing here? What's the magic? The magic is something that you gamers might be familiar with. The magic is they built their own machines using NVMe SSD drives. The big thing that changed here is I/O. The speed between the compute that's actually handling your queries and the storage behind that compute that is allowing this all to interface correctly. The way that compute works on AWS is interesting. At any given time, a node that is running could die and be replaced. Thankfully, in our modern world of compute, we don't expect to have a hard drive we're just writing to and from on our VMs anymore. We usually put our data somewhere else, like a database or S3 or something else. For a database to work on AWS, it has to work the same way. That compute layer that does the work is usually separate from the storage, because the storage in that whole compute unit could die at any point and you don't want to lose data. As a result, basically every database on AWS is writing the data to something else, some form of network storage that it has to go over the network for. Those network speeds are insane because these machines will be like next to each other in a server warehouse with really, really fast lines connecting them, but it's not faster than a PCI lane. The fact that they're using the fastest possible storage, NVMe drives, to directly interface with your compute allows for performance characteristics that didn't seem possible before. And if you think this is a cool thing for small companies, yeah, sure, we're benefiting from it a lot with T3 Chat, but all of Cash App has been using this tech now for 3 months. It's really good. This isn't just something for small startups. Gigantic companies like Intercom and Depot and Block are all making this move. I'm lucky that I got to early as well. Now I'm going to explain why, for some of you, this makes a lot of sense. And again, to be very clear, if the idea of spending $600 a month on your database is terrifying to you, this product isn't for you. But that doesn't mean we don't have lessons we can learn from it, because the infrastructure and the things we see from it as a result are incredible. If we have Aurora with MySQL on AWS, which is the production-ready, recommended, happy path, expensive, correct solution to doing databases on AWS, this Aurora box has multiple parts. It's more of a vibe than it is a box. So I'm going to put the text above it, and we're going to dot this guy. In here, we have a compute node. We actually have quite a few. We'll call it CPU node. The CPU node that we likely have multiple of sits on the edge of this box, waiting for information to come in, waiting for requests, waiting for work to do. These nodes are where a user's request comes in, and also obviously where that request comes out. But these don't hold data. These are treated as ephemeral because at any given time, one could disappear. So we need to make sure that data is being stored safely, which is why Aurora has a network store that all of these nodes are hitting in order to actually store the data. There's crazy work going on here to make sure things don't override each other, that the consistency of queries, all that stuff is handled properly. But the key distinction that you need to know is that there is a network gap between the node taking your request and handling the query and the storage layer that is actually holding the data that we're trying to get to or write to in many cases. This is what's so different with the Planetscale metal model. Instead of the CPU node having to go over the network for storage, each of these nodes has its own storage. So now we don't even really need that dotted box on the outside, because each of these is its own node that handles everything fine. And when a request comes in, it will write the data, read the data, whatever it needs to, and handle replication to all of the other nodes behind the scenes for you. So instead of the source of truth being the network storage that's separated, the source of truth is whatever just had this write happen. This seems super dangerous, right? What happens if one of these nodes collapses at the wrong time, or we have data that hasn't been replicated yet, or all of these weird, painful edge cases? I actually like the way Sam put this when I talked with him, so I'm just going to basically quote him verbatim. This is all part of what Vitess does. In the words of Sam, Vitess was built in the most hostile possible environment. Heard. If you're not familiar with Vitess, it's a way of deploying, managing, scaling, sharding, and doing all the annoying things you have to do for an at-scale MySQL database. It was built originally at YouTube in order to help their databases scale. The team that made it open sourced it, and then a bunch of them went to GitHub, did basically the exact same thing, and realized, oh, a lot of companies need this. They broke off, and they made Planetscale. And that is why it is as performant as it is. That's why they're so focused on enterprise cases. They built it to scale. And now tons of companies, from Slack to Cash App, are relying on their tech, relying on Vitess in order to make their MySQL databases operate at insane levels of scale. Vitess was built a little bit before Kubernetes, and its tech stack is relatively similar. Since it was built before Kubernetes, it was built on top of a thing called Herd, which is like Kubernetes if it was way worse and less reliable. Because of that, the expectation that any one of these nodes would exist at any given time was near zero, and Vitess was built to handle this, to allow nodes to replicate and share data consistently enough that no one node dying will cause you to lose data. The results are nuts. It's truly incredible what type of performance and resilience you get when using Vitess properly. It's not fun to set up. You can do it yourself, but Planetscale is the solution for all of this. You can see that when you hop into any Planetscale database. If I go to my dashboard here, you can see that we have the VT gates, which are the place the connections actually come through when a user is getting data or one of our servers is getting information. We have our primary cluster here, and this has two replicas that at any given time can be fallen back to if something goes wrong with this, and every read and write is being pumped through our primary down to these other boxes. It's nuts. A fun fact Sam shared with me when we were chatting is that all of the nodes in your database on Planetscale are less than 28 days old because they're so consistently cycling and replacing them because it doesn't matter. Their infrastructure is built to handle all of this. And that's why they had the realization of, oh, we don't really need to care about the storage being separate then, do we? Because they had this realization, they wanted to take advantage of it. Since any given storage node doesn't matter as much because they're replicating between each other, we don't have to have a separated data layer. We can just store it on the device, skip the whole network hop, skip all of the weird stuff there, and just write at the speed that your CPU can write. I/O speeds are a very real limitation at certain levels of scale and data transfer. It doesn't matter how fast your CPU is if you're bottlenecked on the network. Now it is impossible to be bottlenecked on the network. As they said, this is unlimited IOPS. Nuts. And the numbers speak for themselves. I showed you the crazy cut we saw, but we weren't on one of these expensive databases before. We were just using the cheaper tier of Planetscale. We saw an insane jump, but that makes sense. We're paying almost 10x more for our DB. How does this compare to existing production solutions like what Google has with Cloud SQL and what AWS has with Aurora? Pretty insanely well, as we'll see. These tests are with a box that has 4 vCPUs and 32 gigs of memory. They have a database that has 500 gigs of data, which is pretty nuts. So we are syncing a ton of stuff with T3 chat, like all of your message history data for the live sync is all stored here. And it's still only 26 gigs of data. Still a lot, but like it's fine. 500 gigs is a lot of data. And as we see here, performance is relatively comparable minus these terrible spikes that the proxied Aurora instance hits. I'm not quite sure what's causing those, but I won't pretend that I can perfectly explain why the proxy causes these random dips every 75-ish seconds. It's almost like perfectly to a T, but it's very real. And I've seen this myself when we're dealing with large numbers of connections and data requests going through a proxy layer. Those layers tend to be latent and cause problems. They were willing to spike the CPU up on it, but Amazon doesn't even give them the option to, which is interesting. When we look at the P99 latency, though, that's when we really start to see a gap. It's as much as 2x faster than the non-proxied layer once you have a large number of connections. So you have 100 connections on each, it's almost 2x. With the proxy, it helps, but you still get those crazy spikes here and there. If we lower this to the 50 connections, you'll see the gap closes a bit, but it's still a lot larger than we'd want to see for a database that costs $6,500 a month. Yeah, Planetscale's alternative here, $1,400 a month. This is actually a value as big as these numbers sound. And some of these QPS hits they're taking are insane. Because again, when it hits those weird latent spikes through that proxy, the throughput plummets. And you end up with numbers that are insane for those like queries. Like here we go from a 700 millisecond P99 up to 2400 milliseconds. That's insane. It's like a 3x plus difference there. Oh, and by the way, this configuration was different. $12,000 a month versus $3K. You guys know me. Whenever I have the opportunity to dunk on Google a little bit, I'm going to take it. And Google Cloud is a mess. Their SQL product does actually seem pretty good for enterprise-sized stuff. But the spikiness here is a little scary. And as we go to the comparison, you'll see just how bad it gets. See how spiky the performance is on Google? You have drops here down to like nearly 0 queries per second. I don't even want to see the latency charts for that. They're going to scare me. That already is terrifying. And if we bump this to that size, you still get like the occasional drop here. Curious what that was for the 200 connection test. But the amount of spikiness here is terrifying. Like you never know at any given time when you fire a query, is it going to take no time at all? Or is it going to take seconds when you have that level of spikiness? And it starts fine too. It just takes 200 to 300 seconds, and then it becomes this bad. And as they said, it just doesn't recover. They call out that you could tune MySQL to figure this out, like in the query side, and your layer is the developer, but they're just using the default configuration here. And this is what we're seeing, which is very, very bad. To be fair though, Google is cheaper if you don't have as much storage, but once you have the same amount of storage, it becomes more expensive. Price is a lot fairer though, so I see why people like Google. If the reason was price and theoretical performance, Cloud SQL does actually sound like a decent option here, but realistically, those crazy latency spikes are not something you would want to tolerate at a database of this tier. And Planetscale is now cheap enough for this type of thing. It's pretty hard to justify anything else. Yeah, when you look at all of the numbers combined here, the only thing that is really consistent is non-proxied Aurora and the new Planetscale metal stuff. Everything else is a bit of a mess. Once you add the proxy layer, you end up with these terrible spikes, and Google's just kind of a joke. If we look here at the P99 times, even comparing Aurora here, Planetscale maintains much more consistent latency. At least the throughput can be handled by Aurora there, but the latency is a big gap. If you look at the proxied version, which remember, Planetscale is effectively proxied through their VT gate, so this is a more fair comparison by what they do. Yeah. This is a really big change for how you make decisions on your database. Previously, you kind of had to pick between the DX of a product like Planetscale or the performance of a product like Aurora because you couldn't be faster than AWS on their own infra. But because Planetscale was so heavy on this Vitess flow, they were able to do something better than what Amazon can do. And the only way they'd be able to compete would be leaning really heavily into this Vitess stuff, spinning up new hardware and rethinking how all of that works together. But I don't know if they're even going to bother because they're still going to make all their money from Planetscale paying the fees and network costs and all of that. This is the first time there is a better option on AWS than AWS. Previously, you were making some level of compromise if you wanted a really performant database and you wanted something that wasn't an official AWS offering. Now the compromise is AWS. You have worse developer experience. You don't have all the fancy stuff around branching, rollbacks, automatic dual writes. I just did a DB migration earlier, and it kept the old version of the database up for 30 minutes and wrote to both of them in case I needed to roll back. Awesome. All of these types of things that are genuinely groundbreaking as a developer trying to ship at scale no longer require a performance hit or a cost increase. Now it is cheaper with better DX, and it's faster and more reliable. That's nuts. I haven't seen anyone successfully do this. The closest thing I can think of is Vercel's Fluid Compute, where there are now theoretical ways they could have better performance characteristics and, more importantly, cheaper prices than what AWS offers. I feel like we're entering a new era of these cloud providers that aren't just AWS or Google. The last era was the developer experience wars, where every company was trying to unscrew AWS DX and make something that was better and easier while taking advantage of all the power of AWS. Now I've gone a step further, where some of these companies are actually building things that are better than what AWS offers, but are still co-located so that your compute, your servers, your processing, all of your other stuff can still be in the same warehouse and still have really, really good performance. It's kind of crazy to think that Vercel and Planetscale are building mini better AWSs within AWS now, but they are. And the numbers speak for themselves here. This is kind of insane. I do love that they have this section, by the way, the is metal always better? There are certain times where it won't be. If you have a small enough amount of data that it's all able to be stored in memory, then you're going to get better performance on the solutions that are storing it in memory and not taking advantage of all this crazy new stuff. And here we can see that the latency is slightly worse than it is on the proxied version, but it also never has those spikes. And it's still almost twice as good as what we would expect from Aurora without the proxies. Kind of crazy. As they call out, when I/O isn't a bottleneck, the benefits of unlimited IOPS effectively go away. But if you're throttled on the data coming in and out, if you're throttled on the storage at any point, which is what's happening with a lot of these spikes, this is an unbelievable product. I am so happy that we have this early, and as terrifying as that price is, and as much as we definitely don't need to be spending $600 a month on our DB, the fact that it will scale effectively forever and the performance is so much better is just one of those edges that we get that makes our experience better for our users. $600 a month for data to sync faster and our users to have a better experience is a no-brainer decision for me. And I'm so pumped we got to try this out early and get some help from the Planetscale guys in order to ship an unbelievably fast database. Let me know what you guys think. And until next time, peace nerds.